If I'm not wrong, the first data service is also under development. Can you give us the state of that project?
In the classic anynines data services, we have multiple data services that are all based and developed and automated using what we call the anynines data service framework. So when we thought about what is the best way to bring this exact user experience to the Kubernetes ecosystem. Now, the Kubernetes ecosystem is a bit different from Cloud Foundry. So, as I mentioned, we are working on Cloud Foundry for Kubernetes. So we already have Kubernetes environments, Kubernetes-based Cloud Foundry environments up and running. Now, if you have such a Cloud Foundry environment on Kubernetes, you also want to have data service automation that will integrate with Cloud Foundry. So we are talking about service brokers again. You need a service broker to consume that data service. And there, I don't think you will care so much whether there's a container or a virtual machine started. As long as noisy neighborhood isn't your primary problem, I don't think a software developer will care. So far, you could assume that just taking your service broker and integrated with Cloud Foundry for based on Kubernetes will work, and it will. If you're using BOSH-based virtual machines and you combine a Kubernetes-based Cloud Foundry with your existing data service, that's perfectly possible. And in some cases, or maybe even a lot of cases currently, that's a good thing to do because these products are very mature. However, the next thought that we have was if we are addressing the broader Kubernetes audience, then there may also be people who do not have Cloud Foundry, and maybe they do not want Cloud Foundry. For example, because their environments are not that big and the CF push experience is not their primary desire, but they have a stronger desire for the flexibility that ships with Kubernetes. For example, wrapping up a legacy application that requires persistent volumes. It's easier to get hosted in a deployment based on, or a stateful set based on Kubernetes than you could do that with Cloud Foundry. And what if you want to provide data service to these folks as well? Then the service broker, as a primary means of integration, requires to have a Kubernetes extension, which is called the service catalog. It doesn't seem to be a very popular project, so apparently the operator concept has a better traction now being in the CNCF, and where the idea is not to make the Open Service Broker API your primary citizen, but to use Kubernetes custom resource definitions, which is basically telling the Kubernetes API how to store object specifications. Like you can specify a service instance according to such a CRD, which makes up, let's say, your Postgres instance. And then you have a controller who will take that specification and talk to the Kubernetes API and translating your Postgres specification into specifications of lower abstractions, and will create a service, a secret, and maybe a stateful set. So that user experience based on operators will allow the creation of CRDs and operators and controllers that will together comprise an operator that, for example, will allow you to create Postgres instances talking to the Kubernetes API directly. And our best guess is that this will be the primary citizen of the future, and that the service broker integration will then be the other way around, so that the service broker in the end will delegate the heavy lifting of the data service automation to the operator. And we believe that at this point, it is still very important to look at several data servers at the same time to have a homogeneous structure of these CRDs, because otherwise the service broker integration will be, let's say, more effort, and user experience for both platform operator and application developers will be decreased, and more operational friction will be observed. So again, to avoid that problem, we are going to create a new data service framework that will leverage the operator SDK as well. And we decided to start with Postgres because it's one of the data services that has challenges because, for example, there's no cluster manager that does leader election. You all have to add that. And so Postgres is a good service to start with. So the point, and coming back to your answer, if you start thinking about Postgres itself, well, there are Postgres operators. There's, for example, one by Zalando. Zalando, in turn, has a Kubernetes and container images called Spilio, which basically wraps the Petroni project. So we've been looking into these products, and they are very good. It's nothing to say against it. But if you think about building a platform where you want to have several data servers sitting right next to each other, and you may have to reproduce these platform environments several times, you really need to have full control over the user experience for both platform operator and application developers. Logs and metrics, backups and restoring backups, they all should, behave in a standardized way. So in order to get there, we dissect that existing operator and strip away anything that could come into our way. So for anynines Postgres, for example, we decided to go with Petroni and reuse part of Spilio for now. Well, we have a feeling that even this will have to be replaced in the long term. Not sure how we could come together with talking to the Zalando team themselves. We haven't done that yet. But what I'm saying is the user experience of building a data service experience based on Kubernetes, it will also require those questions beyond a single data service. But you need to start one implementation to find out whether your working hypotheses can be validated. So not to tell you too much here, but so far this looks good. We're making progress. First product demo will be available at the end of the first quarter for Postgres. Currently, we are working at the user stories of creating service instances. Next will be backup and restore. And then we are looking into collecting logs and collecting metrics and bring that and integrate that together with the rest of the platform. So it's kind of exciting at the moment because there's so many moving parts at the same time. On one side, you have Cloud Foundry being put on Kubernetes, and you have Kubernetes itself, which still is being discussed. What's the right abstraction for it? Are you using the cluster API, or you still want to use a BOSH-based provisioning? And then you have the data service and the framework that's being newly developed. So we are trying to leverage as much of the CNCF projects as possible, as they seem to be stable and well adopted. So that's let's say the building blocks we are using to create that new version of the anynines platform.